guys, it's Hayden here. Thanks for clicking on this video. As you can tell, a little bit longer than normal, and that's simply because I'm going to be sharing with you in a minute one of my premium maths lessons from our website, where we've got hundreds more of this type of lesson. So if you like it, if you get to the end and think, I want some more of this, then go and check out our website, www.topdogonline.co.uk. On our website, you can access hundreds of lesson videos for maths and English, verbal reasoning, non-verbal reasoning, everything you need for your 11 plus, because we've designed a course that lasts a whole year for you to work through. And every single lesson video also comes with a homework task that you can download, as well as answers and even a walkthrough video. And the best bit is for you guys on YouTube, of course, because we love you guys. You love our videos already, so we've made a discount code to make it just that little bit easier for you to access. If you type in TOPDOG20 into the promo code, it will take 20% off of the price. So yeah, do check it out. Anyway, here is a video from the website. I hope you enjoy it. Angle turns is one of those objectives that you don't really learn too much about at school. You'll learn about angles, of course, and you might do a little bit about this, but generally you don't see these question types anywhere other than your 11 plus. So today we're going to dive into this and make sure that you feel like an absolute expert in this area, because I'll tell you what, every single year I have seen one or two of these questions in those 11 plus papers. So let's get to it. We're going to start off with a warm-up. I'll be going through number one with you, and the other four answers will appear on the screen when you're ready. So pause that video and come back for the answers. Okay, here goes the answers. So number 2, 3, 4, and 5 are on there. Notice number 2 went into negative numbers because we're subtracting 5 each time. Number 3, you should be looking for number bonds to 10 just to speed up the adding process. Number 4, nice and procedural. Make sure you get your numbers and your times tables right. And number 5 relies on your knowledge of square numbers. Now, number 1 is the one I want to focus on because you guessed it, I bang on about it every single week. It's got conversion of measurement built into the question, which if you've been with us for a while, you know that we constantly say how this is one of the most important things to learn for the 11 plus because they really do add this in as challenge every single year. So if we're adding 140 centimeters and 2.5 meters, it's not as simple as adding 140 and 2.5. We must convert one of them to the other one. So we could convert centimeters to meters by dividing by 100 because there are 100 centimeters in a meter. That is our key fact here. Okay, so we could call this 1.4 meters, or we could call this, if we times by 100, go the other way, 250 centimeters. So either way, you can get two answers here in meters or in centimeters. In meters, let's start there. 1.4 plus 2.5 gives us 3.9 meters. That would be correct. Or if we were doing it in centimeters, we would have got 390 centimeters. Also correct. All right, so well done if you managed to follow along and that made sense to you. If you're still struggling with this, you've got to go back, you've got to download that conversion sheet and just hammer your conversions. Just make sure you know in like 1 second how many centimeters are in a meter, or how many millimeters are in a centimeter, or how many grams are in a kilogram, all of that good stuff. All right, guys, let's get started then with angles. So first of all, I just want you to pause the video for 1 second, just make sure you know your angle names. All right, so we've got 4 angles on there, 4 names: right angle, acute, obtuse, and reflex. Can you match them up? Right, so let's start here then with right angle. Right angle is this one right here. It's the only angle that we mark with this kind of square effect rather than a nice curve. And this just shows that the angle is 90 degrees. Okay, exactly 90 degrees. We see right angles everywhere. If you look around your room, I bet you could find 5 right angles within 5 seconds because they just are everywhere. The corners of my room, my desk, even the pad that I'm using to write on. Okay, acute angles are, let me just draw my arrow. This is showing us an acute angle because acute angles are anything that are 89 degrees or less. Okay, so they are smaller than or equal to 89 degrees. Okay, they're not. The reason I haven't said smaller than or equal to 90 degrees is because 90 degrees is a right angle. So anything that's 89 degrees or less, we call acute. So usually you won't see it written like that. You will just see it written like this: smaller than 90 degrees, because what that means is it doesn't include the number 90. It has to be smaller than 90. So you've got acute angles there. I'll tell you what, I'm going to write it here next to it for you. And this was 90 degrees. Obtuse angles are shown here. Okay, so an obtuse angle is larger than 90 degrees. Okay, so bigger than 90 degrees, but smaller than what we call a straight line, which is 180 degrees, because that's 2 lots of 90. So quite often your teachers will just show you this. They'll put 90 degrees, to 180 degrees. Just remember that it doesn't actually include those numbers. 90 degrees is a right angle and 180 degrees is a straight line. So it's all of the numbers in between that. And then reflex, as you can see right here, is when the angle keeps bending round and it's actually become larger than a straight line. So a reflex is anything from obtuse all the way to a whole turn. And a whole turn we know is 360 degrees. So let's call this 180 to 360 degrees. Again, we're not including these numbers. 180 degrees is a straight line. 360 degrees is a full turn. Anything in between that, we call a reflex angle. All right, so if you need to write those down, just pause the video at any time and just jot those notes down. Maybe make a little poster. You know, who doesn't want a poster of angles in their room? Okay, so there we go. A bit nicer way to draw it for you to copy down. Let me just move that so you can actually read it. That makes sense. All right, so I'm going to move on. If you've paused it, well done. If not, we're cracking on. So, what can you remember about angles? Now, we did a lesson on this quite a while ago. You might not have been here with us for that. So this is your chance to kind of catch up, have a go. I'm going to let you pause it though, and just see what you can do. Can you find what the question mark angle would be in each of these examples? And if you're not too sure, don't worry, because I'm going to go through it in a second for you. So let's jump into these two on the left here first, okay? So we've got angles on a straight line. We've just been told that angles on a straight line make 180 degrees. So by definition, that angle must add up to make 180 degrees. We can use a quick bit of maths here and simply do 180, subtract the 39 that we already know, and we'll be left with the other part, the question mark. So 180 subtract 39, you can probably just do it in your head by taking away 40 and adding on 1, so you get to 141 degrees. Okay. Down here now, the reason I've gone down here is because for triangles, the rule is exactly the same. All three angles in a triangle also add up to 180 degrees. So that's a rule that we've learned before. So in this one, because we've got three angles here, then we're simply going to add these two together and then just take that total away from 180 because everything that's left must be this third and final angle. So 116 add 19 is nice and simple because I can add 20 and then just take away 1. So 116 would become 136, take away 1, makes 135. And then my second step is to do 180 subtract 135. And again, I can do this in my head. There's no problem with doing it in columns, but if you can do these kind of easier calculations in your head, then that's great. Because what I can do is I just add up from this number. I look at 35 and think how much from 35 to 80? Well, if I added on 5 more, I'd get to 40. And then another 40 to get to 80. So I know that this answer is going to be 45 degrees. So 45 degrees for that one. So those two are nice and simple and very linked because of the 180 rule. Now the next two are also linked because now we've got angles around a whole turn, as you can see, not just a straight line anymore, a half turn. And we've got angles inside of a quadrilateral. Now both of these will add up to 360 degrees, which is exactly double what we were just looking at on the left here. So let's use that rule. So if we've got three angles here, we've got 19 degrees, 95, and something. We're going to use the same logic as we did in the triangle. We'll add up the angles that we know. So 95 add 19, which gets us to 114 degrees. I did the same thing. I added 20, then took away 1. And then we're just going to subtract that from 360 this time, not 180 because it's not a straight line. So if I was to do 360 subtract 114, let's see what answer I would get. Let's do some exchanging. 10 take away 4 is 6, 5 take away 1 is 4, and 3 take away 1 is 2. That means my missing angle here is a reflex angle because it's bigger than 180, and it measures at 246 degrees. Awesome. Exactly the same logic now over here. We've got a quadrilateral. We know what three of the angles are because we know that these right angle symbols mean 90 degrees. So we've got 90, 90, and 132, and something to make 360. So same logic one more time. Add all of the angles up that we know. 90 plus 90 is 180 plus 132. Let's do that with a quick column. Yeah, I'm sure you can do it in your head, but let's just show. 0 plus 2 is 2. 8 plus 3 is 11. And then 1 plus 1 plus 1 more is 3. So we know that those three make 312. And we must do what we did exactly over here. We must now subtract that from 360 because whatever is left is going to be our fourth and final angle. So let's do some exchanging again. 10 take away 2 is 8. 5 take away 1 is 4, and 3 take away 3 is nothing. So our final angle here was actually just 48 degrees. Visually, it makes sense as well. I know it's going to be less than 90 because it's less than a right angle, which would be that. If I got an answer over 90, then I just know straight away that I've done something wrong. And sometimes checking can be really useful, thinking of those things. So that's what we've looked at in the past. Angles within shapes and angles on straight lines or around a point. Okay. The key things to remember are 180 degrees for straight lines and triangles, and then 360 degrees for full turns and quadrilaterals, four-sided shapes. So now we're going to go on to the angle turn questions that you would see in the 11 plus, because they're really interesting, and I'm hoping I can help you a lot with these. So just go on a little bit of a journey with me here. We're going to start nice and easy, but it's going to build up into the questions, and you're going to be like, that makes sense. I get it. So first of all, my first question is, how many degrees are in a full turn? Just tell me, just say it out loud. Don't pause the video. Just how many degrees are in a full turn? Well, we've just looked at that, and it was 360 degrees, right? That's the first important fact that we must understand for every single question we look at today. So our key thoughts for today are this. The sum of the angles at a point, so that means all of the angles going around a single point, is 360 degrees. If we add them all together, we get 360. Then what we're going to do is I'm going to split a circle into a certain number of parts, and you're going to fill in this sentence with me. This point is split into however many parts. Therefore, one part is equal to 360 divided by, and it will be divided by how many parts there are. So let me put that into some context for you. So I split this circle into just, 2 points. So therefore, I've made 2 parts. You could call that part 1 and that part 2. Let's follow my sentence. This point is split into 2 equal parts. Therefore, one part is equal to 360, which is all of it, divided by the 2 equal parts, so that number's always going to be the same, which equals what? So what you're having to do there is 360 divided by 2, but you already know that because we've already looked the other way at how 180 doubles to make 360. So obviously, 360 divided by 2 is 180. So what we've worked out is that each of these angles here, and also there'll be another one this side, are 180 degrees each. Very, very simple to start with. Let's move on. Have a look now. So the sum of the angles, again, around the whole point is 360, but this point is split into how many equal parts? So think about it. Count your equal points here. And then you can see, imagine if we put dotted lines in just to visualize it, how many equal sized parts we've actually split this into. Okay, so we've quite clearly split this into 1, 2, 3, 4 parts, which I could have worked out by just counting the points around. 1, 2, 3, and 4. So we're going to put 4 here. Therefore, one part is equal to 360, the whole thing, divided by 4, because there's 4 parts. So we now must do 360 divided by 4. Again, you can probably see the answer because I bet you can do 36 divided by 4. And we're going to get an answer of 90 degrees, which makes sense. We can clearly see that this is a right angle, right? So now I know that if I turn my arrow from here all the way to here, I have just turned through an angle of 90 degrees. That's the sentence you might use. Okay, so hopefully now you're getting the hang of the kind of idea of this. Depending on how many parts it's split into, that's how many you divide 360 by. For example, I'm going to pause the video this time. What angle if I turned through, if I turn from here to here? Follow my sentences again and come up with an answer. Pause the video and come back when you're ready to see. The sum of the angles at a point is 360 degrees, and this point has been split into 1, 2, 3, 4, 5 equal parts. Therefore, one part is equal to 360 divided by 5, which we're going to do right now. Let's find out exactly what the angle of one of these parts is. 5 doesn't go into 3, so we put it across. 5 into 36 goes how many times? If you know your times tables. 5 times 7 is 35, so we've got 1 left over there. 5 into 10 goes twice. Awesome. So we have just found out that one of these segments is worth 72 degrees. Now, if I was to draw them all in, this is what this really means. It just means we've got 72 degrees here, we've got 72 degrees here. and so on. You get the idea, right, guys? So all we're doing is we're taking that 360, which is the whole thing, and we're just sharing it equally, or dividing it equally into parts. And the amount of parts is determined by how many little notches we've got around the side that are equally spread around the circle. So we divided it by 5. That is the core learning for today, okay? And then we're going to apply this to some slightly harder problems. Okay, so one more of these, and then we're going to go to a new level, okay? This is your last one. I'd like you to pause the video. What angle have we turned through here? So nice and quick then, we've got 1, 2, 3 points. So we've got 3 equal parts that this circle's been split into. So 360 divided by 3, if you can't do it in your head, just do it here, is 120 degrees. So what we've worked out is that is 120 degrees. So is that, and so is that. Okay, there it is. So what would my answer be then? If that was my turn, what if it was no longer just one of these parts? What if I've turned, well, I've actually gone past the first one, I've carried on, and I've got to this one. What is this angle going to be now? And hopefully you can just see that it is as simple as this. If I put this back in, if we know that one of these turns was 120 degrees, and so was the other one, what can we really easily do now to find that total angle? Just add them together, right? So all we have to do now, if we've got more than one part being involved, is that we just have to add those parts together. So, or times them. So we've got 120 and we've got 2 of them. I'm sure you could do that in your head very quickly to realize that in this question, we have turned through 240 degrees, not just 120, because we've gone around 2 parts this time. So sometimes that's the final step of the question. Find out how much angle one part is worth, then look at the question, is it just one part or is it more than that? Because you might need to add a few of those together. So here's a classic example then. This is very much 11 plus level already. So my question is, in this circle here, what angle have I turned around if I have turned around 4/5 of that circle? Which is what I've done, haven't I? 1, 2, 3, 4, and 5 parts, okay? So obviously that's a silly numbering. Hold on, guys, because that makes it more confusing. The first turn, let's call that, we'll come back to that one. This is number 1, that would be 1 turn. This would be number 2. This would be 3 turns, and this is 4 turns out of 5 being the whole thing, yeah? So what's the angle here? I don't know. Pause the video. Have a go. Let's break it down logically. So I know that 1 turn, which is this angle right here, is going to be, because it's been split into 5 parts, it will be 360 divided by 5, which we worked out earlier, didn't we? And we got 72 degrees. So I know that one of these parts is 72 degrees. Okay, excellent. Which means 2 parts would be 144 degrees. And rather than me just adding, I know how many of these parts I've got because I've got to the 4th one. So why don't I just do 72 multiplied by 4? Because that's what I know I want. I want this angle, which is 72, and I want this angle, which is 72 as well. And rather than just adding 72s, which is a bit of a slow method, once I recognize that I just want 4 of these parts, I can just do 4 times 72. So 2 times 4 is 8, and then 7 times 4 is 28. So the answer, quite simply, to this question is 288 degrees. That is how much this black angle, this black line angle is, 288 degrees. Very good. Okay, moving on then. Let's look at some different style questions. So sometimes they won't say, hey, it's been split into so many parts. You can just count the parts yourself. And in a clock, I think it's quite obvious, right? Do you really need to count how many parts are there? Or is there a massive clue in the numbers how many parts are in this question? Anyway, have a go. What's the angle going to be between 12 and 1? If that was making my angle here, marked by the red line, what is this angle going to be? Come back when you've got the answer. Okay, so nice and simple, same logic as before. The whole term would be 360. We've quite clearly got 12 parts here. Okay, so we're going to do 360 divided by 12 to find out what one of those parts would be, which would also give us the answer. So 12 into 3 doesn't go, but 12 into 36 goes 3 times. and then 12 into 0 is 0. So we know that one of these parts is 30 degrees. Amazing. And that will always be the same. If you've got any question now where the circle is split into 12 equal parts, then you know it's 30 degrees. One part is 30 degrees. So let's expand the question a bit more then. What if I turned round to here now? So I've turned round to the 5. What's my angle going to be from here to here? It's no longer going to be 30 degrees because that was just this amount here. But we know that every single part is going to be another 30 degrees. So can you make a shortcut? Come back. Right. Sorry guys, put my drink down. I was trying to be sneaky and drinking the break. Okay, so we know that there are now not just one turn, but 1, 2, 3, 4, 5 parts in total. And if we know each one is 30 degrees, all we have to do is 30 degrees times by 5, and we've got our answer. And if you can do 3 times 5, you can do 30 times 5. It's quite clearly going to be 15 with a 0 on the end, 150. And that's the answer. This full turn here of 5 parts out of 12, we could call this 5/12 of a full turn, couldn't we? That's actually what's happened if we're thinking about it in a fraction. We know that that is equal to 150 degrees. Pretty cool. Okay, next question. There's no numbers on this one, but again, there's a really big clue on how many parts this can be split into because you can count the points on the shape. You can count how many sides the shape has. Have a go. What's going to be the angle there between those two corners of this shape? So my first observation was it is a hexagon, which has 6 sides, which means it has six points as well. So therefore, I'm quite clearly splitting this shape into 6 equal parts. Okay, I can draw them in just to make it visual. If you're ever in the test, don't be afraid to do this, by the way. Your test paper goes nowhere. Only the answer sheet is important. You can draw all over the questions. So therefore, we are, to find one part, which we're trying to find, we must do 360 divided by the 6 equal parts. 360 divided by 6. Again, I know that 6 sixes make 36, so I'm just going to speed myself up here. I know the answer is going to be 60 degrees. Each part is worth 60 degrees. Amazing. I only wanted one of them, so my answer is 60. Now, you know what's coming, don't you guys? You know what's coming. I'm going to give you one. A different question now. I'm not going to give you the same one. A different question where maybe it's more than one part. Just for a bit of fun, though. What would it be if my other black line... I wonder if I can turn it. I can't remember if I've linked this or not, guys. Just give me a second. Aha, perfect. So what if my black line went to there? What's that going to be? 2 ways of solving it. Have a think. 2 ways of solving it are, well, it's now just 3 lots of 60, right? Because if I put that back in there, it's just 60 plus 60 plus 60. 3 times 60 is 180. The other massive clue that is 180 is quite literally the fact that it is a straight line. Well, that wasn't, I just drew that really wonky line. But the black line was a straight line, which we should be able to recognize instantly as 180 degrees anyway. So a silly question, really. Right, there you go. There's your next question. I'm not even going to say anything this time other than it's a compass. And I want you to find this little angle right here, please. Off you go. So following through our sentence starter is just going to be really easy. Watch. The sum of the angles at the point is 360. Cool. This point is split into how many equal parts? Well, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. 8 equal parts. Therefore, one part is equal to 360 divided by 8. Okay, let me just do that then. Let's divide it by 8. 8 into 3 doesn't go. 8 into 36. Let's do our 8s. 8, 16, 24, 32. I can't get any higher. So 4 8s make 32, but I wanted to get to 36. So 32 add 4 more, which is my remainder. Gets me to 36. 8 into 40 goes exactly 5 times. So I know that one part, which we were trying to find, is equal to 45 degrees. And you know what? This is kind of cool because you can actually see this really visually. Because look, I just want you to focus for a minute. Let me get rid of all this. Let me get rid of all of this and just focus on this for me right here. What angle clearly have I just made here? Very clearly, very visually, I've just made a right angle, right? Obviously. Now, right angle is 90 degrees. If I've got a line that's splitting it perfectly in half, what can we do to find those two angles that we've just made now? Well, just half 90, right? And if you know that half of 90 is 45, then it's very easy to recognize a 45-degree angle because you go, oh, look, it's half of a right angle. So that's just a quick tip for you guys in future. If you see something if a circle that's been split into 8 like this, then you immediately know it's 45-degree angles all the way around, 2 45s, making a right angle, which is 90. Cool. Okie dokie. So this should be nice and easy for you then because we've just done most of the maths. It's the same compass, but this time, what would be the turn from here all the way around to here? You could always draw the line in like this to make it really obvious. Pause the video, come back when you can tell me that angle. So, as we've just worked out, each of these parts is 45 degrees. All we have to do is just see how many of those segments we've got, which is quite clearly 3, and just do 45 times 3. That's it. 3 times 5 is 15, and then 3 times 4 plus the 1 is 13. The answer is 135 degrees. That's it, guys. You know, it doesn't get much harder than this. We're there. So knowing that a full turn is equal to 360 degrees is vital. That's clearly the most important fact, wasn't it, today, in order to answer these questions. So I want you to think about how many sections the whole turn is split into and what each jump must be. Let's have a go. We're going to dive straight into some trickier questions now. There's your first one. So classic 11 plus question, bit of words to read. I'm not going to say anything. I'm just going to let you use your knowledge from today now to answer that 11 plus question. Mary is facing east. So do you know what I'm going to do? I put a little arrow here. Cool. She's facing east. She turns clockwise until she faces north. So we're going around this way. She's not at north yet. She's not at north yet. Aha, now she'd be at north. So we're trying to find this reflex angle here. What angle has she turned through? Well, nice and simple. We don't really have to do any maths here because we can recognize the fact that each of these angles is a right angle, right? So I'm going to turn these into squares. And a right angle we know is 90 degrees, and we've turned through 3 of them. So we want 3 times 90 to solve this. 3 times 9 is 27, so 3 times 90 is 270 degrees, and that's my answer. The mistake people make here, guys, is they turn the wrong way. They go anti-clockwise. So just remember, think of a clock and think which way a clock goes round. It goes round that way, doesn't it? So that's clockwise. Anti-clockwise is when you would think about turning the way a clock doesn't turn. So just imagine a clock, think about which way it goes, and that will help you. If you turned it the wrong way and you only went back one segment, you would have got an answer of 90 degrees, which is there because they always put the trap answers in, but of course is wrong. Okay, next one. Read the question, solve the question, come back for the answer. This clock is missing its hands. It's currently 7 o'clock. Okay, let's draw that in then. So 7 o'clock means one of the hands would be going to the 7 and the other hand would be going to the 12. Amazing. What is the larger angle between the two hands? I like this language, larger angle, because obviously it does make 2 angles, okay? We've got one angle here, haven't we? But we have also got this angle this side, and that is the larger one. So we're trying to find what this angle is. Okay, so what can we do to find this angle? Well, this is what we're going to do. We're going to find out what one segment is as an angle. So if I was to put a dotted line up there, let's find out what one segment is, and then we're going to multiply it by 1, 2, 3, 4, 5, 6, 7 segments. Of course, I didn't really need to count that because it literally has numbers going around for me, and I know we're pointing to the 7. So that's our journey. We're going to find the angle of one segment, and then we're going to times it by 7, and that will give us our total angle here, going from 12 all the way around to 7. So because it's a clock, that means there are 12 parts, and if you remember from earlier, when we did 360 divided by 12, we got an answer of 30. So we know that each little segment is 30 degrees. Okay, I'm not going to write it in all of them. You get the idea. And we want 7 of those. So now we're going to do 30 multiplied by 7. And again, I can do 3 times 7. So this isn't a challenge. I can do 3 times 7 is 21. Multiply it by 10 because of the 0 is 210. And my answer is that's it. My answer is 210 degrees. For a bit of fun, what would the other angle be? Well, how many segments is this? 1, 2, 3, 4, 5 segments. So that would be 5 lots of 30. 5 times 30 is just going to be 150 degrees. Is that an answer here? It is. Look, the trap answers are always there. So you have to be so careful to read, because if you didn't read a larger angle properly and you did the other one, you would have done some really good maths, but you would have got the wrong answer, which unfortunately isn't what we want. Okay, here's your next question. Have a go. I like this question because for the first time it's flipping it for us. It's giving the degrees and saying where will we end up. So if it turns clockwise, which is in this direction, through 240 degrees, what corner will it be pointing to? Now, it'd be very mean if the question gave you a number of degrees that isn't something that we're going to get when we find out what one segment is and multiply it by something. It would never do that. So let's just do what we always do. We know that there are quite clearly 6 segments here because it's a hexagon, it's 6-sided. So we're going to do 360 divided by 6, but we remember what the answer is, don't we? Because 6 times 6 is 36. So each segment is 60 degrees, okay? So now let's think, okay, how many segments makes 240 degrees? Okay, so how many 60s makes 240 degrees? Well, one lot of 60 is 60, 2 lots of 60 is 120, 3 is 180, and the only reason I know this, guys, is because it's just my 6 times table, but times by 10. 4 lots of 60 is 240. Perfect. So we know that we've moved through 4 segments to get 240 degrees. So let's get rid of my notes here and just go back to basics then. So we're starting on where the arrow is pointing. If we move one segment clockwise, we've moved 60 degrees and we've got to A. If we move 2, we've now moved 120 degrees and we've got to B. If we keep going with our pattern, we've got to 180 degrees, we've got to C. One more click around, then we've done our full 240 degrees and we've got to D. So D is our answer. Hopefully the logic there made sense for you. Okay, have a go at this question. Same sort of thing, just different context. This circle is split into 12 equal parts. Well, that's perfect because we already know that when we have 12 equal parts, just like the clock, that each part is worth 30 degrees. I'm starting to learn now the degrees for different amounts of parts. The circle is rotated 210 degrees clockwise. Which point is the arrow pointing to now? That's interesting. So when this whole wheel is picked up and turned, the A, B, C, D, and E will stay with the wheel and they'll rotate around as well. Okay, because we're going clockwise. And one of them is going to end up being right here where this arrow is. So the arrow doesn't move. Now, here's the cool thing. I know that every segment is 30 degrees. And I know that there's a link between 3 and 21. I know that 3 times 7 is 21. So now, therefore, I know that 30 degrees, 7 lots of 30 degrees is 210 degrees. Okay, guys? So I know that it's going to turn 7 clicks around. So that's what we're going to do. So this is what it's on right now. Now, if we want to find out where this is going to turn, we've got to find the one that when turned 7 clicks around ends up here. So let's just do a bit of trial and error here. Let's start with E. Are you ready? So if E turned 7 clicks, 1, 2, 3, 4, 5, 6, 7. It's going to end up right down there. That's way too far. Now we can use our logic to work out which one we should be going back to then, because if E was where D was, it would end up here. Okay, and we can just write them in. So C would be the one that comes before it. B would go here, which is our answer, and A would end up there. Do you see how I used E to just write the rest in? Because obviously they just stay one behind them in alphabetical order. So there we are. I used E, did it around 7 clicks. Let's just check I did that right. So that'd be 1, 2, 3, 4, 5, 6, 7. Perfect. 7 clicks, each equaling 30 degrees. That's why I did 30 times 7 is 210. I've completed my question. It's been going clockwise as well. I'm just checking all my information. I'm really happy then that my answer is B. Right, I think this is my last question, guys. I can't remember. I might have one more. So pause the video. It's a bit different because you've got to draw it yourself this time. Draw a compass to help you. Off you go. So just for a bit of fun, I thought I'd chuck this one in because sometimes 11 Plus does this. They make you visualize your own questions. Because we need north and northeast, we're going to need these little intermediate ones as well. That would be north and that would be northeast. Now, lucky for us, if it's moving clockwise, we're literally just going from here to here. And what is this angle? Now, you might remember from earlier on that we don't even need to do maths here because look, there is a right angle, okay? And this is quite clearly exactly half of a right angle. Half of 90 is 45 degrees. So it's one of those questions that rewards you if you recognize and can visualize the question. Now, without visualizing, you might have just sat there and done the maths and gone, okay, that would be 8 parts. 360 divided by A, and then you got 45 that way. Meanwhile, everybody else has visualized it, has seen it, and they've just moved on. I've got one more. Here we are. I knew I had one more. Let me check. Yeah, that's it. This is the last one, okay, guys? So what direction are you facing if you started facing east and turned through 720 degrees clockwise? So the cool little trick here is this, guys. I'm just going to show you. Look, north, east, south, west. So we're starting facing east. Now, the funny thing is 720 is bigger than 360, which is a full turn. So one full turn, east to east would be 360. And if you know your numbers, you'll know that 360 times 2 is 720. So what that essentially means is we're just going to do another full turn, and then we get to 720. We're still facing east. Okay, we just did 2 perfect full turns. There we are. That was a little trick one. Anyway, guys, you know what to do. It's a long old video today. As you can see, we're getting towards the end of the year now. Next week, I've got a really, really long video for you. So be prepared next week. We'll be doing lots of revision because it's our last official lesson before we start our summer package. So go and tune into your homework. Thank you for joining me today. It's been a pleasure. I hope that this objective has not been too horrible for you. A lot of children find it very, very hard. So go back and watch bits again if you found it a bit tricky. And have a go at the homework task and then enjoy the rest of your day. Thanks so much, and I'll see you next week.